superposition theorem. The superposition theorem states that if a linear system is driven by more than one independent source, so if your circuit contains more than one independent source, more than one independent source, right? Then the total response is the sum of the individual responses. This is the statement of your superposition theorem. So what does this says? The superposition theorem states that if a linear system is driven by more than one independent power source, the total response is the sum of the individual responses. Or in other words, we can also state your the theorem: the current through or voltage across an element in a linear bilateral network is equal to the algebraic sum of the currents or voltages produced independently by each source. So what is this meaning of this superposition theorem and these two statements? I will explain here. By taking a simple example, we'll explain here the superposition theorem. Now, refer to this figure 1. We want to find the branch currents using the superposition theorem. So what is your superposition theorem states here? Suppose if you want to find the branch currents like this, the current in the 6 ohms is we have designated as I1, and current in 3 ohms is I2, current in 2 ohms I3, current in 4 ohms we have designated as I4. Right, we have total 4 branch currents, and we want but two independent source. One is voltage source, another one is current source we have. Generally, if I ask you to do find the branch currents, there are two methods you will find. One is mesh analysis use or nodal analysis use. Right, by using the mesh analysis or nodal analysis, you can find the mesh currents or nodal voltages, and from that we'll find out the branch currents. That is one way so far we have seen. Now, in case of superposition theorem, how do we find without applying the mesh and nodal analysis? Yeah, is so the current in any branch of the circuit is the algebraic sum of the responses by each source. And yes, first we'll keep the 120 voltage source and we deactivate the current source. Then we'll find I1, I2, I3, I4, and those currents we designate it as I1 dash, I2 dash, I3 dash, and I4 dash. Where the currents I1 dash, I2 dash, I3 dash, I4 dash are branch currents due to 120 volts source. That is, initially what we do here it is, we keep the 120 voltage source, and by deactivating 12 amperes source, then you may have a doubt that what is meant by deactivating the 12 ampere current source. So deactivating the current source means you look at this diagram here. See here you have a current source. Look at this diagram. You have a current source here, and the current source is to be deactivated by using the open circuit. So current source deactivation means open circuiting this current source. This is as far as the current source is concerned. An ideal current source is deactivated. Deactivation means that is removing this ideal current source and representing it that terminals with the open circuit. Suppose if you want to deactivate voltage source, deactivating. So deactivating the voltage source. So deactivating the voltage source means in this diagram, if you want to deactivate the voltage source, this is an ideal voltage source. So an ideal voltage source is deactivating means that representing it into a short circuit. So this is a deactivating the voltage source, ideal voltage source, and this is a deactivating the ideal current source. This is an ideal current source. So, but some place we also have practical voltage source. So deactivating a practical voltage source means that keeping its internal resistance. This is a practical voltage source, and this is the internal resistance of the practical voltage source. So deactivating the practical voltage source. This is a practical voltage source. So deactivating the practical voltage source means that short circuiting this voltage source and keeping the internal resistance as it is in series with that short circuited terminals. So this is in case of practical voltage source. Now practical current source, in case of practical current source, this is the deactivating the practical current source. So this is a practical current source we have. So practical current source, you well aware that the practical current source is represented with an ideal current source in parallel with its internal resistance or impedance. Therefore, deactivating this practical current source means that open circuiting this old current source and keeping the its internal resistance. So likewise, the when you are applying the superposition theorem, either you have to deactivate the ideal voltage source or ideal current source or practical voltage source and practical current source using this principle. Now in this example, here we have a voltage source here. See here, this is a voltage source we have, right? Here is an ideal voltage source we have and a current source we have. So initially what I will do here is, so when I apply the superposition theorem, then we start with calculating the currents by using the 120 voltage source first. So that is, we keep the 120 volts voltage source and then deactivate the current source. So here, by substituting the ideal current source with open circuit, we deactivate the current source as shown in figure like this. See here, the current source is on open circuit chases on. Now voltage source as it is going to. So now you find out the currents. Therefore, these currents we have designated as I1 dash, I2 dash, I3 dash, and I4 dash. We have designated them as like this. Right. So where I1 dash, I2 dash, I3 dash, I4 dash are the branch currents when 120 volts voltage source is acting alone. That we can write it here, right? I1 dash, I2 dash, I3 dash, and I4 dash are branch currents when 120 voltage source is యాక్టింగ్ ఎలోన్ అంటే అది ఒకటే కనెక్ట్ చేసి ఉన్నప్పుడు అని అర్థం. మిగిలిన సోర్సెస్ అన్ని కూడా జీరో చేసేసాం. రెడ్యూస్ టు జీరో అంటారు, డీయాక్టివేట్ చేయడం. ఇప్పుడు నౌ యూ హావ్ టు ఫైండ్ అవుట్ I1 డాష్, I2 డాష్, I3 డాష్. సో హౌ డు ఐ ఫైండ్ దిస్ I1 డాష్, I2 డాష్ హియర్ ఈస్ జస్ట్ ఇక్కడ నోడ్ అనుకున్నాం, దీన్ని V1 అనుకున్నాం, రైట్? దిస్ వోల్టేజ్ ఐ హావ్ అస్యూమ్డ్ ఇట్ యాస్ V1. దెన్ ఐ విల్ ఫైండ్ అవుట్ V1 minus 120 is I1 dash. See here, V1 minus 120 divided by 6 నోడల్ ఈక్వేషన్ రాసే అనుకోండి. దెన్ V1 minus 120 by 6, V1 by 3 అంటే I2 dash. రైట్. అండ్ V1 by 2 plus 4 ఇదంతా సిరీస్ లో ఉంటుంది. ఇక్కడ ఇదంతా కూడా దిస్ ఇస్ కనెక్టెడ్ ఇన్ సిరీస్. ఎందుకు? సిన్స్ ఇట్ ఈస్ ఓపెన్ సర్క్యూటెడ్, therefore 0 amperes of current will flow. Therefore here I3 dash is equal to I4 dash, right? So this is a nodal equation we will obtain is equal to 0. And then in this equation only you have unknown quantity is V1, and if you simplify this equation then you will get V1 as 30 volts. So when V1 has 30 volts, therefore the equations for the branch currents are given by this. So the branch currents are given by 15 amperes, that is the branch current in this one I1 dash. Yeah. So what is the branch current I1 dash? I1 dash, I can call it as I1 dash is equal to 120 minus V1 by 6. So what is 120 minus V1 by 6? 120 minus 30 by 6, which will be around 90, that is 15 amperes. This is that 15 amperes. All right. Then that is I1 dash you got. Then I2 dash. I2 dash is the current here. So which is given by in terms of node voltage V1 by 30. So sorry, V1 by 3. So V1 by 3, V1 is 30 by 3, which is equal to 10 amperes. See here, we got 10 amperes here. I3 dash here you want, right? I3 dash and I4 dash are one and the same. Therefore, I can write it as I3 dash, which is equal to I4 dash is equal to V1 by 6, which is equal to V1 is 30, 30 by 6, it is 5 amperes. Here is given as 5 amperes. So likewise, so in the first case, this is case 1 and case 1 and when case 1 when 120 volts source is acting alone, right? So case 1 ద్వారా మనకు వచ్చిన కరెంట్స్ ఇవి. ఇది ఫస్ట్ కేస్. Then we'll take the case 2. Case 2 here is, so we deactivate, see here we deactivate the voltage source. ఇక్కడ deactivating the voltage source, మనం voltage source deactivate. ఇక్కడ already voltage source ఉంది కదా, we have replaced with short circuit here and keeping the 12 volts amperes. This is case 2. So case 2 is when 12 amperes current source is acting alone and deactivating 120 voltage source with short circuit. So the circuit, this figure represents that case 2. So this is the figure representing your case 2. Now under this condition, these are all we called as branch currents I1. So the branch currents, these are all I1 double dash, I2 double dash, I3 double dash, I4 double dash. Even the branch currents under case 2, right? So now let us find out these branch currents. So these branch currents we will determine by using the once again nodal analysis, right? So here we assume it that this is a voltage V3 here and a V4 voltage is, right? Then this is our I1 double dash and your I2 double dash is in this direction, and this is your I3 double dash and your I4 double dash is like this. So now for this one, if you apply nodal voltage V3 by 6 and V3 by 3 is this current, V3 by 6 and E current, and V3 minus V4 by 2 is equal to 0. This is the first nodal equation, right? Then the second nodal equation is V4, that is here V4 minus V3 by 2 is this, and V4 by 4 and in the current V4 by 4 is that, and 12 amperes current is this, is equal to this one, and this is the second nodal equation. Now, by solving these equations, what we obtain here it is V3 is equal to 12 volts and V4 is equal to minus 24 volts. And from that one, we can find out I1 double dash. What is I1 double dash? I1 double dash is the current in this direction. Right. So how do you find the current in this direction? I1 double dash. Voltage E across this one is V3. So V3 minus V3 by 6 is the I1 double dash, which is given by 2 amperes. Then I2 double dash is the current in this one, I2 double dash, which is the V3 by 3. So that we have written here V3 by 3 is the I2 double dash, and V3 is 12 volts. Yeah. Therefore, minus 12 volts by 3, which is equal to minus 4 amperes. Then V3 double dash, I3 double dash is equal to I3 double dash, and the current in this one in the from node 3 to node 4. And V3 minus, we can write I3 double dash as V3 minus V4 by 2. So other I V3 minus V4 by 2, where V3 is 12 minus 12 and V4 is minus 24 minus of minus plus, you will get by 2, which is equal to 6 amperes you will get. Then I4 double dash is the current here in 4 ohms resistor downwards. So which is equal to I4 double dash is equal to V4 by 4. Here V4 is minus 24 by 4, that is minus 6 amperes. So likewise, you got the I1 double dash, I2 double dash, I3 double dash, I4 double dash. These are the branch currents. These are the branch currents when 12 amperes source is acting alone. Right. So when 12 ampere source is acting alone, these are the branch currents. So according to superposition theorem, what is your superposition theorem states that is to find the actual current of both the circuits, add the currents due to both the current and voltage sources. So voltage source ద్వారా వచ్చిన current source ద్వారా వచ్చిన currents రెండు యాడ్ చేయడం. ఇదిగో I1 single dash అంటే is the current branch current I1 due to voltage source. I1 double dash is the branch current I1 in due to current source. Similarly, these are also like this. So take the algebraic sum of this, then what we'll get is I1 dash in the already 15 వచ్చింది, అది plus 2 17 amperes, 6 amperes, 11 amperes and 1 minus amperes if you substitute. So this is what we called as the superposition theorem. So from this one, so superposition theorem లో మనం ఇందాక చెప్పినట్టుగా ఏమంటో చెప్పాము, superposition theorem what does it states? It is the algebraic sum of, see here, the superposition theorem states that in a linear circuit, if it is driven by more than one independent source, power source, therefore the total response is the sum of the individual responses. And sum of the individual responses అంటే ఇందాక చెప్పిన కేసులో I1 dash plus I1 double dash అదనమాట. Right. So this is how the superposition theorem is applied to solve this problem. Then the limitations of superposition is the superposition theorem does not work for power calculations. So and it is useful, we can able to find the only voltage and currents in branches. But power key formula ilaga some of the algebraic sum of the powers we cannot use. So because the power calculations involve either product of the voltage or current, and the square of current or the square of the voltage, so they are not linear operations kabatti. So power key, this superposition theorem, power calculation superposition theorem is not applicable. Then superposition theorem cannot be applied for nonlinear circuits, that is such as diodes, transistors, etc. And this method has a weakness. In order to calculate load current IL or the load voltage for the several choices of load resistance of the resistive network, one needs to solve for every source voltage and currents perhaps several times. So with the simple circuit, this is fairly easy, but in large circuit, this method becomes a painful experience. ఎందుకంటే every time you have to calculate ఎన్ని సోర్స్ ఉంటే అన్ని సార్లు మొత్తం టోటల్ క్యాలిక్యులేషన్స్ అన్ని చేయవలసి వస్తుంది కాబట్టి it is a complex circuits వచ్చేటికి ఏంటంటే somehow is a painful experience when we use the superposition theorem.